Colleagues, good morning. Mr. Nambane. Colleagues, good morning.
Good morning, Mr. Sefo, you are audible.
Okay, I was just wondering whether I'm audible enough to everyone. Colleagues, I am Mr. M.I. Sefo, the subject advisor from Leisurely Puja. Then I will be taking you through this memo discussion. And we agreed that we'll start exactly at 8:15. And I think we must be mindful of time because there is another memo discussion that is coming on for grade 11 at 11 o'clock. And colleagues, we can start. And for better running of the discussion, if you have any points to raise up your hand, but I will say let us discuss each question. At the end of each question, then we can entertain the questions. Question 1, multiple choice. It stays like that from 1.1 up to 1.10 as per the marking guideline that you have, unless there is any deliberation that any one of the colleagues have. But we have checked and verified that. Then I can see there is a hand from Cornell Scabot. Yes, ma'am, or say yes.
I just want to check, is the meeting being recorded?
Yes, the meeting is being recorded and then the video will be made available later today. But just check, Mr. Nambane is now engaged in the provincial moderation in Bloemfontein. Therefore, the time when the recording will be available might be delayed by some hours, but definitely it is being recorded.
Yes, that is it for.
Yes, Mr. Nambane. All right, colleagues, and then we'll also yes, Mr. Nambane. Colleagues, I will also request that if you are in a meeting and there is nothing that you want to add or ask, please keep your mic muted. And therefore, let's go towards question 2. In question 2, it reads thus: consider a wave generated by jerking the string up and down, and the direction of propagation is perpendicular to the disturbance. The distance from A to C is 7.5 meters. And I guess colleagues are aware that that point C has twisted a little bit. But now there is a wave there. And then question 2.1.1, it says write down the name of the wave explained by the underlined statement. And therefore the name of that for 1 mark will be a transverse wave. Even if that wave is not there, a minute a learner says transverse, then that learner will get 1 mark. And then 212, how many wavelengths are there from point A to point E? It is only 2 wavelengths also for 1 mark. And then 213, what is the name given for the disturbance from point A to point C for 1 mark? I know the memo that you are having says it refers to a pulse, but the correct answer there will be a wavelength also for 1 mark. And 214, if the mic unmuted, colleagues, can we please mute yourself and then so that you cannot disturb this. And 214, point A of wave diagram moves a distance of 15 meters in 3 seconds. There is someone, colleagues, with his or her mic unmuted, and then there is that noise behind there. Can you please mute yourself? Mr. Mahapi or Mr. Kleinhans, can I ask that you just check on the screen if someone is not muted? Can you help with muting everyone who's causing the disturbance behind? And this is second for cluster guest. The mic is not muted. Please, colleagues, help us to run the memo discussion smoothly. And then let's go, colleagues. Point A in the above wave diagram moves a distance of 15 meters. Memelani, can you please switch off your video and your mic, please? Thank you. Point A in the above wave diagram moves a distance of 15 meters in 3 seconds. Then 214, calculate the speed of the wave. And therefore 1 mark will go for the formula V is equals to change in X over the change in T. 1 mark will go for the substitution 15 divided by 3, the whole of substitution. And then 1 mark will go for the final answer with the correct units, that is 5.5 meters per second. And therefore 214, take note that from 214B, there is a positive marking from 214A. And therefore in 214B, we are calculating, learners were requested to calculate the frequency of the wave. And then the formula there will be velocity or the speed of the wave is frequency multiplied by lambda, 1 mark for that. 1 mark for the whole of substitution. 5 for V that was calculated, remember positive marking. And then the final answer becomes 0.67 hertz. Or some learners will go towards calculating frequency using the number of waves over time. A learner will be aware that he has got 2 full waves, and then he divided that 2 full waves by the time taken, which is 3 seconds, and then he will basically arrive at 0.67 hertz. 1 mark for the formula, 1 mark for the substitution, and then 1 mark for the final answer. And then number C, learners were requested to calculate the period of the wave. And then the formula for calculating the period will be, the period is 1 over the frequency, 1 mark for the formula, 1 mark for the substitution. Remember, this is also positive marking from 214B. And then 1 mark for the what? 1 mark for the final answer, which is 1.59 seconds. And therefore that will go for 3 marks. And then question 2.2 uses a sonar to measure the depth of the ocean. An ultrasonic sound is sent and reflected sound is received 1.2 seconds later. And therefore 221, they were requested to define or explain the term echo in words. And then for 2 marks, and then it is 2 or nothing, colleagues. Echo, it is the reflection of the sound waves. 2 or nothing, there is no part marking there. Then 222, they were requested to calculate the depth of the seabed while the speed of the sound in water was given as 1,530. Therefore, 1 mark will go for the substitution for the formula. Speed is equal to the change in distance over the change in time. And then the distance is 1,530. Therefore, the time there, take note of the time must be 0.6, which is 1/2 of 1.2 because we are calculating the distance. And therefore 1 mark for the formula, 1 mark for 1,530 independently, as well as 1 mark for 0.6 x divided by 0.6. And then that will give you x of 9.8. And therefore we will only allocate a mark when the learner interprets that the depth is 918 meters. There is also option 2. In option 2, you can just note that the same mark allocation for the formula for the substitution of 1,530, but now this learner uses 1.2, which is the time for the sound waves to move and then for an echo to be heard. Then he arrives at a distance of 18.36, but because we are calculating the depth, then that learner will divide that 1836, 1,836 divided by 2. Then he will basically arrive at 918 meters. And then the total mark for that question 2 will be 18. And I'm not sure if there is any question on clarity seeking question on question 2, then we can entertain that. But if there is nothing, then we can move on. It goes once, twice, and therefore it means there is nothing. Therefore, we can move to question 3, colleagues. Question 3. The sun emits all radiation in the electromagnetic spectrum. All this radiation moves through space at a speed of 3 multiplied by 10 exponent 8 meters per second. And then that is the electromagnetic spectrum that is given. And then 3.1, learners were requested to give 2 reasons why all these waves are placed in the same family of waves that is known as the electromagnetic radiation. I guess that must be something that will be common to all of them. And therefore, 1, we are looking for 2, they travel at the same speed. All electromagnetic radiation travels at the same speed, and they are propagated through a vacuum, all of them. And then all of them possesses the particles and the wave properties. It means that will be only 2 marks for the first 2. And then 3.2, name the type or kind of radiation that can be used in 321 cell phones. That will be radio waves. Even if a learner says radio waves is in brackets. 322, determining the fractures in the bones, that will be your X-rays. And then 323, in the communication satellites, that will be your microwaves or your radio waves. And then name 2 properties of the electromagnetic waves. We are looking for 2. Therefore, they originate from accelerating electric charges. That is 1 property. They are propagated by varying electric fields and magnetic fields, such that these 2 fields are at right angles to each other and at a right angle with the direction of the propagation of the waves. And then they travel in a vacuum. Their speed is 3 multiplied by 10 exponent 8 meters per second. Those are the 4 that we are looking for, the first 2. And colleagues will be warned that please, when you come across a property as in bulletin number 2, you must please read that so that whatever that the learner has written makes sense, because I know because of swapping of the weight, sometimes it does not make what? It does not make sense. And then for 3.4, they must write down the relationship by a quantum of electromagnetic radiation and the penetrating ability of the what? And the penetrating ability of that. Therefore, the energy transferred and the penetrating ability, they are directly proportional. That will go for 1 mark. And then 3.5, a red laser radiates light with a wavelength of 700 nanometers. A green laser radiates light with a wavelength of 500 nanometers. Then 3.5.1, which laser will radiate more energy per photon of light. And then for 1 mark, that will be what? That will be green. And then 352, they must use a calculation to support the answer in question 3.5.1. And I guess this is one question where the memo has been altered and it does not look the same as the marking guideline that you have. Because we are now comparing the two to make a conclusion. We are going to allocate, it means a learner must have got 2 calculations, 1 calculation for the red and 1 calculation for the green, so that it can be able to make a conclusion. And then for 4 marks, this is what we are going to, how are we going to allocate the mark? 1 mark will go for the formula, energy is HC over lambda, 1 mark. Either that in a green or a red, whenever you see that formula allocated at 1 mark. 1 mark will go for the whole of the substitution in the what? In the red, if everything is correct. And 1 mark will also go for the whole of the substitution in the green light, if everything is correct. Therefore, also take note that nanometers must be converted into the meters. No mark for the what? No mark for the answers there, but 1 mark will be on the final answer that the energy of the green light will be greater than the energy of the red light. Therefore, that will be your 4 marks. And then 3.6, they were required to calculate the energy of a photon of a gamma rays with a frequency of 3 multiplied by 10 exponent 20 hertz. And then that will be 4 marks. I know we will get some lashing on this because of the mark allocation. 1 mark will go for the formula. 2 marks will go for the substitution. We decided that we needed to test whether these learners can use the data sheet, and then hence we allocated 1 mark for correct substitution of the value of the Planck's constant and 1 mark for the frequency. And then 1 mark will go for the final answer of 1,99 by 10 exponent negative 13 joules. And therefore that will be your question 3. And then the total mark for question 3 will be 17 marks. I'm not sure, colleagues, any question, clarity seeking question? It goes once, it goes twice. Therefore, in the absence of any question, then let's move towards question number 4. In question number 4, there is a statement given at the top there, and then the statement reads thus: a learner in a physical science class rubs his hair with a plastic rod. The rod becomes negatively charged. The learner now opens a tap so that a thin stream of water runs from it. When the rod is brought closer to the water without touching it, it is observed that the water bends towards the rod as shown in the diagram below. And then question 4.1.1, they were required to write down the principle of conservation of charge in weights. And then for 2 marks, the net charge of an isolated system remains constant during any physical process. That is true or nothing. And then 4.1.2 for 2 marks, they were required to give a reason why the stream of water bends towards the rocks. There is a stream of water that is bent towards the rod. And therefore, what is the 2 marks, and then what is the allocation of mark? Water is a polar molecule, and it will polarize such that the positive sides of the water molecule will be attracted by the negative charge of the rod. Therefore, that is part marking. If a learner is a polar molecule and then it will be polarized such that the positive side of the water molecule, it means there must be something that is said about the positive side of the water molecule being attracted towards the negative side of the rod, because what you can see is that your rod on that side that is near water, it is negatively charged. And then 4.2, 2 small metal spheres, that is metal sphere B and C, on insulated stands, each carry a charge of, one has got a charge of positive 2 multiplied by 10 exponent negative 9 coulomb, and negative 6 multiplied by 10 exponent negative 9 coulomb respectively. And therefore there is a diagram there. And then for question 4.2.1, how does the number of electrons on sphere B compare to those on sphere C? Write down only less than, more than, or the same as. The correct answer is less than for 1 mark. Then for 4.2.2, the learners were required to give a reason for the answer to question 4.2.1. Therefore, because sphere B is positively charged, or it has a shortage of what? Has a shortage of electrons. Therefore, that is quite an answer there. Sphere B is recharged, or a learner can explain that by referring to what sphere C, saying that sphere C is more negative, or it has got an excess of what? It has got an excess of electrons. Therefore, that is 1 mark. Then 4.2.3, the 2 spheres are now allowed to touch, after which they are separated and returned to their original positions. And then 4.2.3, in which direction are the electrons flowing while spheres B and C are in contact? Write down only from B to C or from C to B. Then the correct answer is from C to B. And then 4.2.5, 4.2.4, I mean, give a reason for the answer in question 4.2.3. And therefore, I guess the answer will be electrons moves from a sphere with an excess of electrons to the one with a shortage of electrons. And then take note that it is what? It is 2 marks, and then it is part marking. Moving from sphere with excess of electron to the one with a shortage of what? With a shortage of electrons. And therefore that will be question 5. And then 4.2.5, they were required to calculate the charge on each sphere after they are separated. And then what is the charge on each sphere? 1 mark for the formula. Charge is Q1 plus Q2 over 2. That will be 1 mark. 1 mark for the whole of that substitution together with the signs. And then 1 mark for the final answer, negative 2 multiplied by 10 exponent negative 9 coulomb of charge. And then the total mark for that question will be 12 marks. Let's invite questions and inputs, colleagues, if there are any. It goes once, twice, and therefore it means we are doing quite good. Question 5. The sketch below shows an electric circuits with various components. The EMF of the battery is 24 volts, and the instrument labeled X registers a reading of 3 amperes. Then 5.1, there is a sketch there, 5.1.1. They were required to use the correct symbols to draw the above circuits. And therefore, this is the circuit that we expect them to draw. But I will draw your attention towards what? Your attention towards the marking criteria. 1 mark, we are going to allocate the first mark if X, or instead of X, Elena might give a correct symbol of an ammeter. If that is connected in series, it must be there and it must be connected in series for you to allocate a mark. And the 2 ohm resistor must also be connected in series. It means X and 2 ohm resistors must be in series too in the circuit. And then if you have got Y, that is component Y, or Elena instead of Y can say a voltmeter. And then for you to allocate that mark for that voltmeter or Y, it must be connected in parallel to a 2 ohm resistor. It must be in parallel to a 2 ohm resistor for you to allocate that mark. And then the other mark will be when your 24 ohm resistor and your 8 ohm resistor, they are connected in parallel. Then you have got another mark. And then the other mark will be when Elena has shown that we have got what? We have got a battery here. Or if Elena has given a cell, then it means we are looking for a symbol of a battery or for a symbol of a cell. And we can also accept if Elena has just written a power source there. And then that will be your 5.1.1. Please, colleagues, look at the marking criteria for you to be true. They were required to define the term EMF in weights. And then what is EMF? It is work done per unit charge by the what? By the source. That will be 2 marks, 2 or nothing. And then 513, how much energy can basically your EMF. Then 514, the reading on the instrument Y across the 2 ohm resistor is 6 volts. And therefore write down the name of the instrument labeled Y. That will be your voltmeter. And 515, they were required to determine the potential difference across the parallel core combination. And therefore, across the parallel combination in 5.515, they must be aware that now they have got they are given the EMF, and they also know the EMF across the 2 ohm resistor and the voltage across the 2 ohm resistor. Therefore, the EMF must be the sum of the voltage across the 2 ohm plus the parallel combination. 1 mark for the formula, and then 1 mark for the substitution, and then 1 mark for the final answer. And colleagues, we will accept if learners uses Ohm's law, but we know that some teachers will introduce their learners to Ohm's law, although Ohm's law is not part of the what? Is not part of the grade 10 syllabus. But in future, let us be aware so that we teach 521. In terms of the Ohm's law, maybe I must just explain and then colleagues will take notes. In terms of the Ohm's law, it means a learner will be aware that across the parallel resistors, he will calculate R parallel. And then once he calculated that R parallel, that will be, he will now use Ohm's law to say R is V over I. That R parallel will be 6 ohm. And then R is V over I, that will be 6 multiplied by 3. Then that will be what? That will be 18 volts. That will give him exactly the same answer. Then in 5.2, 121.5 joules was used in 3 seconds to transfer charges between the ends of the 8 ohm resistor. And therefore, 521, calculate the charge transferred in 8 ohm resistor in 3 seconds. Therefore, that charge will be the current, which is equal to the rate of change in charge, that is I is equals to Q over delta T, that will be 1 mark for the formula. 6.75, remember positive marking from 5.2.1 over 3, and then the final answer will be 2.25 amperes. We'll also accept in 5.2.2 if a learner have used the Ohm's law. But just make sure that 1 mark goes for the formula, 1 mark for the substitution, and then 1 mark for the final answer. Then 522, yeah, that was 522. 5.3, calculate the total resistance of the parallel combination. 1 over R parallel is 1 over R1 plus 1 over R2, that goes for 1 mark. And then 2 marks substitution, and then 1 mark will go for the final answer. But take note, colleagues, that if a learner does not conclude that therefore R parallel is equals to 6 ohm, that means that learner will only get 3 out of 4, because you would have said 1 over R parallel is 1 over R1. Therefore, at the end of the day, he must conclude that R parallel is equals to 6. Also quite aware that some learners will use this because there are 2 resistors there. R parallel is the product of the what? The product over sum. Therefore, we expect the learner to say R parallel is R1 multiplied by R2 over R1 plus R2. Then that will get 1 mark. And then 1 mark for 2 marks for the substitution. 1 mark on top, 2 marks for the substitution, and then 1 mark for the final answer. That will give you a total of 4 marks. Then question 5.4. They were required to calculate the resistance of the circuit, the total effective resistance of that circuit, and therefore RT will be R parallel plus RS, and then that will be 6 plus 2, and then that will be what? That will be 8 ohm. Therefore, only for 2 marks, 1 for the substitution, and then 1 for the final answer. And therefore, colleagues, that is that in terms of question 5. I'm not sure if there is any questions that we can entertain or addition towards what has been discussed. It goes once.
Mr. Sifu? Mr.
Hello,
Sifu?
ma'am. Yes, ma'am.
Marisa Smith speaking. I just want
Yes.
to know that EMF definition, it differs from the exam guidelines than from that new booklet that the department sent for the grade 10s, because on page 32 in that booklet, the definition says the maximum amount of energy transferred through the battery per coulomb of charge. So now it's
Yes.
different. Can we accept both of them?
Yes, let us accept both of them.
Okay, thank
All
you.
right. Thank you, Marisa. Any other input or clarity seeking question? Then, in the absence of that, let's go towards question 6. Colleagues, in question 6, there is someone with his mic not muted, colleagues. Ipupeng. Colleagues, can we please mute ourselves? Colleagues, can we please mute ourselves? Right. Colleagues from Ipupeng. Right. Colleagues, in question 6, let me make this upfront. We don't know what happened there. When you look at the keys there is sodium, there is chlorine, there is oxygen, then there is hydrogen. But when you look at the substances A, B, C, and D, especially in A and D, you now start to see something that is irrelevant, that is not on the key, the one with the vertical lines that are bold enough. Therefore, colleagues from Ipupeng, colleagues, can we please mute ourselves, please? So it's like something happened that we cannot explain either during printing or during conversion towards PDF. That is one thing that I want to clarify on that. Compound A was basically meant to be a sodium. And that D in D, therefore, in D, it was basically a sodium. And then in A, it must be a sodium what? It was meant to be a sodium chloride. Therefore, I'm not sure how you maneuver around that, but we will try to reach a consensus in terms of that question. Therefore, 6.1, learners were required to define the boiling point. And that boiling point is defined as the temperature of a liquid at which its vapor pressure is equal to the external atmospheric pressure for 2 marks, 2 or nothing. And please read so that whatever definition is given can make sense. And 6.2.1, 6.2, use the diagram and the key provided to answer the following questions. And then write down the letter of the diagram that represent, and therefore 6.2.1, a substance that is a solid at room temperature, and therefore that will be a or a D. And then 6.2.2, a substance that is a gas at room, that is a gas, and then that will be B. And then question 6.3, we have got the heating curve of a substance that is shown below. And then 6.3.1, in which phase is the substance at negative 20 degrees Celsius? Therefore, that will be a solid for 1 mark. 6.3.2, at which temperature does the substance melt? And then that will be a temperature of 0 degrees Celsius. And therefore 6.3.3, state the phase change that takes place at X. At X, we are changing from a liquid to a gas. And therefore, the total for that 6 point, there is now another statement there that leads us towards 6.3.4. The temperature remains constant at X. Explain this phenomena in terms of the space and the forces between the what? The forces between the particles. Therefore, that will be for 4 marks. 1 mark will go when the learners state that the kinetic energy of the particles remains the same. And that energy is used to overcome or break or weakens the intermolecular forces between the particles. That will go 1 mark. Another mark, that will be your 2nd mark. And then the particles moves away from each other. That will be another what? That will be another mark. Resulting in the what? Resulting in a phase change. That will be what? That will be another mark. That will go for 4 marks. And therefore, the total for that question will remain at what? Will remain at 4 marks. I can see that there is something that is asked on the what? On the chat box, but I could not see what was asked there on the chat box. Can we entertain this in the form of questions or inputs, colleagues? Question 6.
Mr. Sipho?
Yes, ma'am.
6.3.4, the grade 10s haven't done intermolecular forces as yet. That second one for an increase in potential energy. Instead of, say, it's the intermolecular part. So can't we take there the part that says there's the kinetic energy remains the same, but there's an increase in the potential energy.
So what we are saying is that no intermolecular forces up to this point.
Yeah, there's nothing done in grade 10 about intermolecular forces, so they won't answer that question or teach them. We teach the either the kinetic energy increases or stays the same, and then the potential energy increases or stay the same. So can't we take that second one? There was an increase in the potential energy of the molecules.
Right, let me digest this. The kinetic energy of the particles remains the same. We give 1 mark.
That's
Yeah, particles moves away from one another. We give 1 mark.
Yeah.
Resulting in a phase change, we give another mark. Then you are saying?
Yeah, that statement about the intermolecular forces, can't we change that to the potential energy increases?
EP increases. EP of the molecules increases.
Yes.
I'm just wondering, when we teach this is on kinetic molecular theory. Yeah, but let's give 1 mark there. Therefore, it means that mark, let's say that to the intermolecular forces. But in case then that learner refers to the intermolecular forces, then we will allocate that 1 mark.
Yeah, so they must then either the intermolecular forces or the potential energy then.
Yes. Then there is another hand. I'm not sure whose hand is that one. Yes,
Mr. Sefo.
Yes, sir.
Yeah, actually, the question that Ms. Smith is asking, it boils down to what we are saying about the kinetic molecular theory as referred to.
Yes.
Now, it boils to the reasoning that the particles, the question that fact that basically there are forces that are holding them together. It is not about particles are not moving or whatever. It is just because it is because there are intermolecular forces. So I understand where she comes from. It is how they are teaching it, but the reality is not that. So let's talk to the reality and not only talk to what we taught.
Okay. I guess that was an input, Manier. Yes, I'm coming to you. Yes, Mr. Ntien.
No, this is Mr. Mohapi.
Yes, I wanted. Yes, Mr. Mohapi.
Yes, no, I just wanted to highlight the questions in the chat. Ne? We have 2 questions in the chat.
Yes.
One from Mr. Daizani, who asked about positive marking. Do we have positive marking from 5.1.5 to 5.2.1 and 5.3 to 5.4?
Yes, that is one question. The other one?
So, okay, and then the second one is from Melanie B. She asked with regard to question 6.3.3, may we accept evaporation?
Yes.
Yes, those are the 2 questions in our chat.
Okay, thank you, Mr. Mohapi. Colleagues, what Ntate has alluded to, it is basically what I wanted to say, that whenever you talk to kinetic molecular theory, it means we are talking about the behavior of the particles in different phases and then how they behave. Therefore, one way or the other, you must be talking about the forces between the particles and the forces between the atoms. But in any way, we have already accepted that, but let's correct that. And then let's go towards question 5. Mr. Titan, from 5.1.5. 5.1.5, we are calculating the V parallel, and that V parallel, which is 18 volts, is used in 521. Yes, we can accept positively. And 5.3, we are calculating the R parallel, and then that R parallel is used in 5.4. Yes, we can still accept positive marking there. And let's go towards 6.3.3. 6.3.3 is asking about the phase change. It's not asking about the process. Phase change is liquid to gas. But if you say evaporation, it is the process where a liquid changes into a gas. But the question was clear. It was asking about the phase change. What is the phase change there is liquid to gas. Then I don't think evaporation will be relevant in 6.3.3. Any other clarity seeking question or inputs, colleagues, before we move?
That is a
Yes, ma'am.
on the case of the intermolecular forces, it's correct that we don't teach learners with respect to intermolecular forces. It's the same situation that the identity is explaining. From it starts in grade 8, the content of change of state. So it is explained in terms of forces of attraction, that the forces in solid are stronger as compared to a liquid, and the forces in liquid are stronger than in gases. So not intermolecular forces per se. So it will be incorrect if we teach them only in respect of kinetic energy, because as Dadinsi said, although solid is not moving, it is because of those strongest forces of attraction that are within those molecules.
Yes, ma'am. Point noted. Any other? There is a hand. I don't know whether it is an old hand or it is a new hand. If you have raised your point, colleagues, then lower the hand so that we can move on. There is a hand. I can still see a hand, but I'm not sure whose hand is that one.
Master Sefo?
Yes,
I
ma'am.
have a question in 5.1, where we are referring to a battery. When line are supposed to draw a circuit, they are supposed to draw a battery of 24 volts, but on the circuit diagram, we have a cell. So when we introduce this in grade 8, we have one cell and two or more cells, then becomes a battery. But in the situation right now, we only have one cell. Is it acceptable as a battery?
No, it is a cell, but look at the marking criteria. Marking criteria, we said we'll accept if a learner has drawn a battery that has shown two or more cells, or if a learner has given a cell, we'll still accept, or if a learner has written a power source.
Thank you.
Thank you, ma'am. Any other clarity seeking question? The hand that I'm seeing, is it an old hand? Therefore, it means we are fine, colleagues, we can move on. Then we go to question 7. Question 7, first question was a definition of an isotope. They are atoms of the same element having the same number of protons or atomic number, but different number of neutrons or mass number. Therefore, that is part marking. Atoms of the same element having the same number of proton or atomic number, 1 mark, but different number of neutrons or mass number, then 1 mark. Then question 7.2, study the unknown elements A to E below. and therefore they are given there in terms of the atomic number and the mass number. And therefore 721, which of the elements above are isotopes of each other. Therefore, the isotopes of each other will be A, N, and B because they have got the same atomic number, 1515. And then 7.2.2, write down the name of the isotope named in question 7.2.1. And then because they are element number 15, therefore they are the isotopes of what? Of phosphorus. And then 7.3, they were required to calculate the relative atomic mass of copper by using the following isotopes. Copper 63 with its percentage is given there. And then copper 65 with its percentage given there as 30.85 and then 69.15 for copper 63. And then what is the allocation of mark? The relative atomic number will be that, therefore we give 1 mark for 69.15 multiplied by 63, and plus we give another independently 30.85 multiplied by 65, and then when he divide by 100 there we give 1 mark, and then we'll give the final mark as 63.62, and then that will go for 4 marks. And then question 7, complete the following table. Write only the answer next to the question number 7.4.1 to 7.4.5. 7.4.1, they were looking at the number of neutrons on the magnesium isotope, and then that number of neutrons will be 14. 7.4.2, they were looking for the number of electrons on the magnesium isotope. That number of electrons will be 12. And then 7.4.3, they were looking for the element there. That will be your sulfide ion, S2 minus ion, S2 minus for 2 marks. Or a learner can write a sulfide, then he will get the whole 2 marks. If he writes sulfur only, he will only get 1 mark. But he must be able to say it is a sulfur ion. If sulfur only, he will get 1 mark. Then the other mark will go for the ion, and therefore that will be your 7.4.3. 7.4.4, the atomic number in that sulfide ion will be 16, and 745, the number of neutrons there will be 16, and therefore that is that for question 7.4. Question 7.5. In organic fertilizers like ammonium nitrate are produced from ammonia NH3, which is manufactured industrially through the Haber process. 7.5.1, write down the chemical formula of ammonium nitrate for 2 marks. We give 1 mark for ammonium NH4, and then we give 1 mark for NO3, that is part marking. And then 752, write down the name of the bonds between the atoms of ammonium. That will be your covalent one. That will be your covalent bonds. And then 754, 753, give a reason for the answer in question 752. And then the answer there will be they are sharing, that bond is because of the sharing of unpaired valence electrons, or it is the bonds between the one, between
Mr. Sefu, there's no sound on our side. I see that you are muted.
Sorry. When did you lose me? Can
At
I find out?
7.5.3.
7.5.3. Okay, no, thank you. 7.5.3. The sharing, give a reason for the answer in 7.5.2 is because of the sharing of unpaired valence. Lena can say this is the bonds between the what? Between the non-metals are the non-metals. And therefore 754, they were drawing an Aufbau diagram. 1 mark will go for the 2 electrons in the 1s orbitals with opposite spins, colleagues. 1 mark will go for the 2 electrons in the 2s orbitals with opposite spins. 1 mark will go for the 3 electrons in the what? In the 3 orbitals with the same direction. And therefore 755, they were now supposed to draw a Lewis dot diagram for the ammonia molecule. And therefore that is the Lewis dot diagram for the ammonia molecule. And therefore that Lewis dot diagram for the ammonia molecule, marking criteria says that we will allocate 1 mark for any lone pair shown there. 1 lone pair, there must be 1 lone pair there, that is there. And then we'll give 1 mark for any shared electron pair between the nitrogen and the hydrogen. Any shared pair of electrons between the nitrogen and the hydrogen, that will get what? That will get 1 mark for 2 marks. And that will take the total for that question to 23. May I invite questions or additions? Seems as if everything is fine in question in question 7. Then we go to the last question, that is question 8. In question 8, the weight equation 1 and unbalanced chemical equation 2 for 2 chemical reactions are shown below. Equation 1, nitrogen gas react with the hydrogen gas to give the ammonia gas. Equation 2, 2NaHCO3 solid gives off Na2CO3 solid plus H2O liquid plus CO2 gas. Then question 8.1, which one of the reactions, 1 or 2, is a decomposition reaction? A decomposition reaction will be reaction 2. It is a synthesis reaction. A synthesis reaction will be reaction 1. Then 8.2, write down the chemical name for NaHCO3 solid. The chemical name for NaHCO3 is carbonate. Then for 3 marks, we'll allocate the following. Sodium will give 1 mark, hydrogen 1 mark, and then carbonate will give 1 mark. That will go to 3 marks. Then 8.3, write down the balanced equation for chemical equation number 1. Therefore, 1 mark will go for the product, for the reactant N2 plus H2, and 1 mark will go for NH3. And then the last mark will go for the balancing. That will give you a total of 3 marks. Reactants 1 mark, balancing, reactants 1 mark, product 1 mark, balancing 1 mark. If the learner does not indicate the faces there, the gases, then we can ignore and give 1 mark. Therefore, even when a double arrow is being used there as a reversible reaction, you can even ignore that and then give 1 mark. Give all the three marks. And then question 8.4, for equation 2, where sodium hydrogen carbonate forms sodium carbonate plus water plus carbon dioxide. The learners were requested to show by calculation that mass is conserved. Therefore, the marking criteria goes like this. The learner must be able to calculate the mass of the reactant and calculate the mass of the product and conclude that the mass of the reactant is equal to the mass of the product. Therefore, we are going to allocate 1 mark. If a learner has given you 23 plus 1 plus 12 plus 48, 3 multiplied by 16 for the reactants, then we allocate 1. And if a learner multiplied that reactant by 2, then we give another mark, but there is no mark there. And then if a learner say 2 multiplied by 23, if everything in terms of the mass of the product is correct, then we give 1 mark. Then the other mark will go for the what? Will go for the equating or concluding that the mass of the reactant is basically mass of the product, then we give 1 mark. And therefore, colleagues must be aware that this anyone that is given here is not for the formula, but anyone will mean that if everything here is correct, then we'll give 1 mark. It means, in essence, what we are saying is that if a learner noticed that out of all the masses of sodium hydrogen multiplied by 2, then he will get 2 marks there. And then out of all the masses here, he has substituted everything correctly there, he will get 1 mark. And then the other mark will go to the mass for concluding that the mass of the reactant is equal to the mass of the mass of the product. Then to make marking easier, it means if anything goes wrong in terms of substitution, it means that learner will forfeit 2 marks because this mark will be gone and then this mark of anyone will be gone. And then that will be your question 8.4. Can I invite additions to and clarity seeking question to question 8.4, colleagues, if there are any, before we move to question 9?
Mr. Sifu,
Hello, ma'am.
8.3, are we going to follow that marking criteria? They must write something on the left side. There must be a single or a double arrow and something on the right-hand side. They can't just write us N2 plus H2. There must be something left and right. Yeah,
it means, thank you for that. For you to be able to allocate this 1 mark for the reactants, there must be that arrow. If that arrow is not there, then you cannot allocate the mark for the reactants. Happy, ma'am? Any other thing on question 8, colleagues, before we go? It seems as if we are happy with question 8. Then we can go to question 9. Then question 9, colleagues, I can see Memo Tau, your hand is up. Memo Tau, you can unmute and ask a question. I saw your hand was up. Memo Tau, or was it a false hand? Right. To question 9, colleagues. Question 9. Potassium and water react according to the balance equation below. There is a potassium solid plus water liquid that gives you potassium hydroxide plus the hydrogen gas. During the reaction, 5 grams of potassium react with water to produce hydrogen gas at standard temperature and pressure at STP. Question 9.1, write down the value of temperature and pressure at STP. This one was a given of. It is given in the data sheet. Temperature 0 degrees Celsius or 273 Kelvin. Pressure 101.3 kilopascals or 1 atmosphere, 2 marks. And therefore 921 they were requested to calculate the number of moles of potassium. Therefore, 1 mark for the formula, number of moles is mass over the molar mass. 1 mark for the 1 mark for the numerator, 1 mark for the denominator, and then 1 mark for the final answer, 0.128 mole or 0.13 mole. And 9.2 calculate the following, the number of moles of potassium. Colleagues, here we have got some changes here. Taking note that for them to be able to calculate the number of moles of for them to be able to calculate the volume of hydrogen in 9.2.2, those learners had to use the stoichiometric calculations, the molar ratio from the balanced chemical, the molar ratio of potassium. And we became quite aware after that they have not yet done with the stoichiometric calculations the molar ratio. Hence, we decided that instead of marking 9.2.2 out of 4 marks, we'll mark it out of only 2 marks. And then what will be that those marks? We'll only allocate a mark for the correct formula. N is equals to V over Vm. That formula will get 1 mark. And because now the 0.064 comes from the ratio, not yet done that ratio, then we are not going to allocate a mark for that, but we only allocate a mark for 22.4. That is the molar volume of gases at standard temperature and pressure. And therefore, it means that question 9.2.2 will only be 2 marks, not 4 marks as it is on the what? On the memo. And then take note, 1 mark for the formula, 1 mark for the what? 1 mark for only the molar volume of gases at 22.4 decimeter cubed. And then 9.2.3 also goes the same because they were supposed to calculate the mass in grams of the potassium hydroxide produced. Therefore, they were also supposed to use the molar ratio to find the number of moles of potassium. And because we felt that this will be unfair, then we are now saying that we will also allocate 1 mark for the formula, number of moles is mass over the molar mass. And we will allocate only 1 mark for the what? 1 mark for calculating, for indicating the molar mass of potassium as 56. And therefore that will be that will be 2 marks instead of 4 marks. And then when you look at that question 9 will now mark up until 9 instead of 13. And the total of that question paper will be 146 instead of 150. Colleagues, can we invite questions, clarity-seeking questions, as well as additions to the memo, if there are any?
That is it for.
And I didn't see it.
Just a reminder to colleagues that when they go to exams, then it means they have to rework the totals and not put the 150 and rework the percentage. We want raw marks on the SSMs. That is the only thing that I can contribute to now. Thank you.
Can you repeat again, Tatentien?
I was saying, now that the paper is going to be marked out of 146, when we punch the marks on SSMs, it still reflect 146 and not 150. So colleagues didn't rework the total to 150. They should just put the raw marks and change the totals on the SSMs to be 146 and not 150.
Okay. All right. No, thank you, Tatentie. Colleagues, what Tatentie is experiencing a challenge if there is this conversion, etc., etc. If the paper is out of 146, just change the raw marks on the what? On the SSM to 146, and then you just transfer the marks of the learner directly from the SSMs instead of doing a lot of conversion. Any other inputs, colleagues, before we adjourn the meeting?
That is for
Ma'am,
Memo Tau.
yeah, Ma'am Tau, I saw
Or
your
Garam
hand.
Tau. And that is for 8.4. If the
8.4.
right the total mass of the reactants is equal to the total mass of the product, and he substitute everything on the left that is equal to on the right. So
He
that
started by saying the total mass
of the
of the
reactants
product, of the reactants,
is
is
equals
equals
to
to
the
total mass
total mass
of the
of the
product.
product.
Yes, Ma'am Tau.
So that means at the beginning, that line have already concluded. And he
Yes.
substituted everything correctly.
Yes.
So is that line going to get all the marks?
This is the same thing as going towards proving whether collision is elastic. Ma'am Tau, I will say that if everything is correct,
Yes.
let's credit full marks. But colleagues, let's go back and then teach our learners that because this is a calculation, they are proving by means of a calculation. They must show the masses, they must calculate the masses separately. I'm just going to be lenient because we are dealing with the grade 10s here.
Yes,
For now. Then it must be understood that for now we are dealing with the grade 10s. Therefore, let us just be lenient with them. But as we go back, let us teach them the correct procedure.
And again, Tadesifu, can I take you back to question 9? Is it really fair for our learners at grade 10? Because this standard temperature and the standard volume, it will be on the next term, but it was asked this term because it was only Avogadro's constant molar mass and how to calculate the molecular. We're expecting the question that was asking about the molar mass using the Avogadro's constant, the molecule, because it was for this term. But coming to that one of a standard volume, a standard temperature, it is really fair for our learners for this mark. Because only one learner asked, what about it? And then I say it's supposed to be on the next term 3, where we're going to deal with the stoichiometry. Is it really fair for our learners for 9.1?
For 9.1.
Yes.
I do understand where you come from, House Emma, but when you check as I said, it is basically given on the what? It is basically given on the data sheet that we have got the standard pressure, we have got the standard temperature. It is just to test whether can they use the data sheet, because basically the answers are there on the what? On the data sheet.
Yes.
Okay, Austin.
Okay,
Was that your hand, Emma, or is there any other hand? Because I can see a hand, but I am not sure whether it is your hand or what.
It seems
okay.
It was mine.
All right.
Good morning,
No,
Mr.
thanks.
Sefu.
Yes, ma'am.
That is okay.
This is Renee.
Yes, Renee.
Hi, sir. I have 3 questions. Can we just look at 214? Question
314.
2.
Question 3.
No, 214.
214.
Yes. Some of my learners used a different formula because of math. Now the question asked for them to calculate the speed. Can we accept the formula where it's V is equals to D over delta T?
Yes, that is acceptable, Renee.
Okay, and then question 222.
222, yes.
Okay, some of my learners, they went and then they calculated the frequency first. Then they said T is equals 1 over F, and then 1 over 0.6, and then they got 1,67 hertz, which is fine. But then the formula that they used for the next step there, they used V is equals to F times lambda, where they were asked to calculate the depth. Do you think we can accept that formula with the lambda if they asked for depth? Because calculation-wise, it's correct.
It means they did not use the time.
They used the calculated.
Or they used the time to calculate. They used they calculated the period using 0,6.
Yeah, the frequency using the yeah.
Then they have got the period of that.
The frequency.
They found the frequency of that.
Yes, yes.
And then from the frequency, they use V is F lambda.
Yes.
Which is basically your speed, which is 1530, multiply by 1.67.
Divide
by
1.67.
What are we dividing there?
The frequency.
Frequency of 1.67.
Yes.
Look, Rene, you said they are using V is F lambda.
Yes.
And then they have got the speed, they've got the speed of 1530.
Yes.
And then they have got the frequency of 1.67.
Yes. Then they calculate lambda.
They calculated lambda.
Yeah, the answer ends up being 918 meters, but the principle, I'm just concerned there with the principle with the formula because depth was asked and now they use wavelength.
As I'm here, I'm trying to draw the wave pattern.
Can I come in there?
Okay, Ntatensia. Yes, Ntatensia.
Yeah. With Rene, I think the learner is not understanding this asked there about the distance. The distance cannot be equated to the wavelength.
Yes.
Because in the first place, that speed that is given there, it's true, it is the speed that we calculated. But does it mean any distance then will be equal to the wavelength? That is going to be a $1 million question. So for that, I think if we are too lenient, maybe we can give at least a 3. Otherwise,
you.